server overhead in terms of GPU.
Sorry, what was that?
I said, so obviously TCP requires a three-way handshake to establish this connection. How does it handle like delays or like how does it do it like overhead? Because wouldn't that take up a lot of overhead?
Every time there's a packet sent, there's a timer, and when a timer times out, the connection is lost. So it'd have to send another packet. Yeah.
Is this used in like video games and stuff? Because I see TCP scroll across the screen sometimes.
Well, TCP actually is just sort of like a general protocol, but usually it is because it can either be TCP or UDP depending on sort of what's going on. Because a lot of times it can be UDP because it needs to just send data. You need to send data fast, and and you might not necessarily need to have like a super consistent connection.
And it is TCP most of the time, and there's a flag on the header that says that it doesn't want to wait for additional packets. Everything just sends automatically. So if packets are lost during that time, then that's fine. It just wants to as many packets as possible.
Actually, on here, I didn't get to talk about it, but where is it? Yeah, urgent. This is basically, it says, I want to send everything now. Stop whatever you're doing and I want you to get this. It's used for multiple reasons. It's like if you need to stop a process on a remote host, you send the urgent packet with saying basically, stop right now, I need you to do something else. And it's also just used to say, I want everything to go through. So.
Which one for you? And you?
6.
Jittery? Not. I guess just. I'm trying to remember. It's been a while since I read this. You can do. I guess it's actually your area probably because you did congestion and stuff, and that would probably be. Yeah, like just sort of like I know that. One of the things that the network will do is it will look at the network, or the TCP will do is it'll look at the network and say, okay, this is the way the network is. This is like this is the properties of the network. I'm going to change. I can't you can't change the header obviously, but you can change the size of the packets. You can change the rate that the packets are sent. You can change certain aspects of the way you send data to account for that. And that's built into TCP. It's designed to say, this network has got this problem. This is how I'm going to compensate for it.
So it's kind of a diagram, then like it says like header length right there, and like it kind of relates to the problem that you have in the exercise. But like with the reserved and code bits, like what exactly is like the difference between the two of those?
The reserved are just actually this is a bit. This is a bit out of date. This is actually 4 and 8 now. They actually added a couple code bits. But basically this is just reserved for expansion. There is a set header size, and they put it in and said we need some space to expand in case we design stuff, and they actually ended up using that later on down the line when they added in, I believe it was congestion. It was either congestion control or some other specific feature. I don't remember off the top of my head which one it is, but they added in extra code bits out of this reserved spot. So.
What does the ACK bit do in the acknowledgement field?
What?
What does the ACK bit, ACK bit do in the acknowledgement field?
The acknowledgement bit is a part of the header, and if it's set to true, that means that it received. Yeah, sure. It received a sequence number. Okay. So the acknowledgement would be the sequence number plus 1. So host 1 now realizes that host 2 got the message, got their sequence number, and is sending it back to host 1. So that's the acknowledgement number. It's just a sequence number plus 1. That's all it is.
About that, does it have to send the acknowledgement? I mean, can the client request no acknowledgement or vice versa? In other words, can it be optional?
I don't believe so. I think that's just it's the three-step handshake that's just required for the connection. Yeah. Like Blur. He asked a question about connections, and I'm not quite qualified enough.
Oh, I had just asked, is the acknowledgement mandatory? Can the client say, you know, can the client connect to the server or vice versa and the acknowledgement not be sent? Or they're like one of them requests, hey, don't send me an acknowledgement. I want to connect, but just don't send me an acknowledgement.
An acknowledgement is needed for a connection. However, it doesn't have to send one back if it doesn't want to. Like when there's a send flood, you know, when there's a DOS attack, and the host 2 is getting all these sequence numbers, it doesn't have to send anything back. But a lot of times it encrypts those sequence numbers and sends them back to host 1. I'm not 100% sure what that does, but apparently it fixes it. But yeah, for a connection to be established, there needs to be an acknowledgement. Okay, cool. Thanks.
So how many types of sockets are there? Do we use only one socket that's indexed, or like are there different types of sockets?
The socket
API.
The socket is really just the just a term for just the connection point, because each machine has what's called a TCP entity on it. Any machine that supports TCP has a TCP entity on it. It can be in a library, it can be in the kernel. Oftentimes it's actually coded into the kernel of the operating system, or it can be on the network card. But that entity will create a socket. There's not, to my knowledge, I didn't research sockets extensively, but to my knowledge, it's just a socket is just the term for a connection point from the perspective of the outside world. The socket is just the external way that other machines can connect to my machine. There's not really any different types, to my knowledge.
I have a question. You had on that chart before, where the three-way handshake, what is an example of, for that second case, the simultaneous connection? When would that be into effect?
Like, when would that happen?
Yeah.
It said, like, at the same time, so I'm assuming before host 1 receives a response, host 2 sends something. And then what the book said was, only one of those connections is going to be established, because that's all that's needed is one connection. And it's based on the endpoints. So I'm assuming it's the first one that connects.
Okay.
Yeah. But it'd be, once the connection is established, that's the one that's going to connect.
Okay.
Which group were you?
Yeah, I think you raised yours first.
9?
So building off of that, if one of them just completely fails to do anything, like say the signal request or whatever from the server side to the client doesn't go through, if the client side still manages to actually finish the process, then it doesn't matter that the other one failed?
Well, no, I'm saying it can't. I don't think it can finish the process. I think like if I send something to you and you don't send anything back, it's gonna trip the timer. I'm gonna send it again if you don't keep sending anything. I guess the best way I can say it is probably would just keep sending it, and then at some point it would just say, stop trying to connect to this. Yeah,
It would time out.
Yes. Oh, yeah, you had a question.
Is there a limit in the number of connections I can establish with a specific server? If it's gonna accept an infinite number of connections, for instance, HTTP or FTP, or is it limited to a certain number?
There is oftentimes what's done is since again it is point to point, each connection is only between two people. But a machine can have multiple connections going on at once, because you can have a game going, you can have the internet going to a website, you can have a bunch of stuff happening at once. That's obvious. So what often happens is there's a daemon, or a daemon, it's a bit odd how you pronounce it, but that runs on the TCP, that runs on the socket, that says that it's just sitting there listening for connections. And then what that daemon will do is when it gets a connection, it'll take this is often on a server that has multiple processes. It's a bit, and I guess nowadays with computers now, but on a server, for instance, it'll fork a process off and say, okay, this process is now going to handle this connection. I'm going to keep listening for more connections. So that's the way that you can accept it. And I'm assuming there's a theoretical limit at some point. It's probably just having to do with the amount of bandwidth the server or the machine can handle, but that's how it would do it. It can handle multiple connections. It's designed to handle multiple connections. But it can only be between, I can't connect to 3 different people and have that be one connection. I have to have 3 separate connections to 3 different machines. Yes.
Yes.
Oh, are you distracted?
Yeah, I was going to say that there is, I don't believe that there is a limit to the number of connections. It will keep accepting connections until you cannot handle it, and you will get service and available error eventually. That's what happens with denial of service attacks, basically. We have any other questions? Okay, so